Welcome viewers, in this video we'll see the solved problem based on the test on single phase induction motor, that is in order to draw the equivalent circuit. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive, the link is given in the description box. Now we'll go to the topic, solved problem, test on the single phase induction motor in order to draw the equivalent circuit. Now see the statement of the problem. A 220 voltage single phase induction motor has the following test result. We know that we have two tests available, no load test, blocked rotor test. No load test, that means no load voltage, no load current and no load power. V0 220 voltage, I0 6 ampere, W0 350 watts. Then blocked rotor test, it is nothing but a short circuit. Short circuit voltage, short circuit current and short circuit power. VSC 125 voltage, ISC 15 amps, WSC 580 watts. Then stator resistance is 1.2 with direct current. Estimate the power factor and efficiency when the slip is 0.05. So we need to find power factor, then efficiency. The slip is given as 0.05. I will see the given data based on the statement. The data given is V rated V1 220 voltage, V0 220 voltage, because in no load test we are applying rated voltage, so that V1 equal to 220, I0 equal to 6 ampere, W0 is 350 watts, VSC 125 voltage, ISC 15 ampere, so this is the rated current, WSC 580 watts, R1 DC equal to 1.2 ohm, R1 AC equal to 1.5 times of R1 DC. The formula is available. So that is equal to 1.5 into 1.2, it is 1.8 ohm. R1 DC is 1.2 ohm, R1 AC is 1.8 ohm. Using the formula we calculate. S equal to 0.05. Right. First we will find the power factor. Power factor is cos pi 1. This, how will you find this cos pi 1? I1 equal to V1 by Z equivalent. By calculating V1 and I1, we are able to find cos pi 1. I1 is V1 by Z equivalent. V1 is nothing but 220 voltage. It is already given. Then what about the Z equivalent? Z equivalent is Z1 plus ZF plus ZB. Z1 is nothing but stator impedance. ZF is impedance of the forward rotor circuit. ZB is the backward rotor circuit. We know that the single phase induction motor is working on the double field revolving theory. That is one stator with two imaginary rotors. One is rotating in forward direction, one is rotating in backward direction. That's why we have Z of ZB. Right? So in order to calculate Z equivalent, we need to find Z1, ZF, ZB. First we will see how to find the Z1 value. Z1 is nothing but R1 plus JX1, stator resistance and stator reactance. R1 is given 1.5, 1.8 ohm. The X1, X2 is not given. That is equal to X equivalent by 2. What is that? X1 equal to X2. Under no load condition, there is no slip, so X1 equal to X2. So X equivalent equal to X1 plus X2. Both are equal. So that 2x1. So X equivalent equal to 2x1. So x1 equal to X equivalent by 2. So now we need to find X equivalent. So that we are able to find the x1. From that we can find Z1. Right? So first we are finding Z1. Then we will go for ZF. Then by ZB. Right? Now we will see how to find the X equivalent. So X equivalent equal to square root of Z equivalent minus R equivalent square. We know that this is the reactance equal to square root of impedance square minus resistance square. Actually what is the formula? Z equivalent square equal to X equivalent square plus R equivalent square. So from that we calculated this reactance. Z equivalent equal to VSC by ISC, short circuit voltage by current. 125 by 15, it is 8.33 ohm. Then R equivalent equal to WSC by ISC square, that is power equal to I square R. From that R equal to power by ISC square. Using that formula we are finding. WSC is 580. Short circuit current is 15 square. That is 2.577 ohm. Now we calculated Z equivalent and R equivalent. From that we can easily find the X equivalent reactance. So these values are substituted. Then we calculated X equivalent equal to 7.9245 ohm. So from that we can able to find X1 and X2, thereby Z1. X1 equal to X2 equal to X equivalent divided by 2. This value divided by 2, that is 3.9622 ohm. So now we are able to, we have the value of X1, X2 as well as R1. So we can easily find the Z1. Z1 equal to R1 plus JX1, that is equal to 1.8, what we already given. This value is already given. Then X1, what we calculated, 3.966 ohm. Right? Now we calculated the Z1 value, stator. Then we'll go for forward rotor circuit, ZF. Then we'll go ZB. Right. So ZF equal to, the formula is JX0 into R2 by S plus JX2 divided by R2 by S plus JX2 plus X0. So this formula, this equivalent circuit of induction motor, separate video available. In that the explanation given how we got this formula. That is nothing but these two are in parallel. Z1 into Z2 divided by Z1 plus Z2. Based on that it is calculated. So in that X0 we need to find. We need to find the X0 value. How to find the X0 value? VAB equal to I0 into X0, so that X0 equal to VAB by I0. This formula also available in that video. Right. So in order to find X0, we need to find VAB as well as I0. What is VAB? V0 minus I0 of R1 plus R2 by 2 plus JX1 plus X2. So this divided by S refers to forward rotor circuit. 2 minus S means backward rotor circuit. Right. So in this formula V0 is available. It's given 220 voltage. That is no load voltage is nothing but rated voltage. Right. Then how will you find the I0? I0 equal to I0 of angle pi naught. Negative, because I0 is lagging the voltage. The I0 value is given 6 ampere, no load voltage, no load current. Pi naught equal to cos inverse omega naught divided by V naught I naught. This is a general formula. Actually what is that? This omega naught equal to V naught I naught into cos pi naught. From that we calculated. So substituted, values are substituted. We calculated 74.62 degree. So that I naught equal to 6 of angle 74.62. Right. Now we calculated the I naught value. We now need to find VAB. By calculating VAB, we are able to find I naught. By finding I naught, we are able to find the ZF. Right. Now we'll see how to find the VAB value. In order to find the VAB, what we need is R1, R2 value, X1, X2 value. R1 value is given 1.8 ohm, but R2 is R2 divided by 2. That is equal to R2 we need to find. In order to find the small r2, capital R2 is needed. What is that? R equivalent equal to R1 plus R2. So this is the total resistance of the circuit considering stator and rotor. From that R2 equal to R equivalent minus R1. R equivalent already we calculated 2.577 minus that R1 is 1.8. So it is 0.777 ohm. So that R2 equal to capital R2 divided by 2. So it is 0.3885. So now calculated R2 value. R1 is already given, R2 is calculated. Similarly, we need to find X1 and X2. X1 is already given. X1 value is already given. X1 equal to X1, small x1 equal to capital X1 equal to capital X2 equal to X equivalent by 2. right? That is 3.9662. It's already calculated. In previous case, it is already calculated. Now see this, all the values are available, R1, R2, X1, X2, right? Now substitute all this value. V0 is no load voltage, 220 rated voltage. Current just now we calculated. R1 is 1.8. R0, R2 is 3.33, 3885 we calculated, plus J is X1 3.9662, X2 1.9811, right? This one we calculated, X1 we calculated, X2 already available. So now all the values are substituted. By simplify, we can simplify this. These two can be simplified, these two can be simplified. So by simplifying that, we got this value 220 voltage, and these two values are simplified, and this is converted into rectangular form. In order to multiply 6 with angle of 74.62 is converted into rectangular form. Now we can multiply this. Real term and image are multiplied. When it is multiplied, we got this value. This polar form also converted into rectangular form. 0 degree simply J0. So by adding this, we got this value that is converted into polar form. Polar form, rectangular form converted into polar form, it is 182.4 with an angle of 0.653. Now we calculated VAB also, right? So from that we can easily calculate the ZF. Our final aim is ZF. X0 equal to VAB by I0. VAB just now we calculated. I0 also calculated. That is 30.4 with an angle of 75.273. X0 equal to 2 into X0. Capital X0 equal to 2 into small x0. So 2 into 30.4, it is 60.8 ohm. Right. Now all the values are available. So now we can able to find the ZF, forward rotor circuit impedance. So what is the ZF? Jx0 into R2 by 2 plus Jx2 divided by R2 by S plus J of X2 plus X0. That is nothing but Z1 into Z2 divided by Z1 plus Z2. Now all the values are available. X0 is 30.4. R2 we calculated 0.3885 plus J 1.9811. Then R2 by S. This R2 by this is not 2, this is S value 0.05, right? So here also it is substituted. Now we can simplify this. So these values are multiplied, then it is simplified like this. Now we can divide these two by converting to polar form, then you can divide. So we got this value that is multiplied inside, so that 6.4752. I think this simplification you know very well. So these two are divided. So this one should be converted into polar form. This also converted into polar form. Magnitudes are divided and angles are subtracted. Again that is converted into polar form. Right. So this multiplied inside. So finally we got 6.4752 plus J 3.41088. So this is the forward rotor circuit impedance. Similarly, we can find the ZB. That will be easier because here more values are we already calculated. X0, X1, X2 are calculated. So we can easily calculate the ZB value. ZB equal to Jx0 R2 divided by 2 minus S. That is the only difference. Backward rotor circuit. Forward rotor circuit R2 by S only. So these all the values are we know. Only the difference is 2 minus 6. So that is substituted. All the values are substituted. Then it is simplified. So again same thing. It is directly given. This term should be converted into polar form. This term should be converted into polar form. Then divide, subtract the angle. So we'll get the resultant. That is again converted into rectangular form. Right. Now it is multiplied inside. So that what we got 0.17556 plus J 1.86048. Right, now we calculated ZB also. So Z1, ZF, ZB, three parameters are calculated. Now we can go for Z equivalent. Now we'll see how to, from these three parameter, we'll find the Z equivalent. So we can now be able to find the Z equivalent. Z1, ZF, ZB is already calculated. From that we can find the Z equivalent. Z equivalent equal to, substitute the value Z1, ZF and ZB. Now add the real term and imaginary term, so that this 8.45076 plus J 9.2234. This rectangular form is converted into polar form, so that we got magnitude is 12.5 and the angle is 47.53. So now we calculated Z equivalent. Our first parameter we need to find the power factor. So I will see how to find the power factor. So from Z equivalent we are able to find I1 equal to V1 by Z equivalent. V1 is already given 220 voltage. Z equivalent what we calculated. So by dividing this 220 divided by 12.5 we got 17.6 with an angle of. So this divided means you have to subtract 0 minus 47.53. So it is minus 47.53. So the magnitude is what we got, 17.6 ampere. I1 is nothing but current flowing from the input, this stator. So power factor equal to cos pi 1 equal to cos of, this is the pi 1 value, right? This angle pi 1 minus 47.53. So it is 0.675 lagging, because of inductance it is lagging, given as lagging. So one parameter we calculated, efficiency, the power factor. Next one we need to find the efficiency. Now we'll see how to find the efficiency. So we know that efficiency equal to power output divided by power input into 100. What is the power output? Power output equal to mechanical power input minus rotational losses. Then power input is V into V1 I1 cos pi. So these values are already available. We need to find P out, Pm minus rotational losses. What are the rotational losses? It's nothing but no load loss, omega naught, 350 watts. So this can be taken from no load test. Under no load losses happen, that is called a rotational loss. That is the constant loss. That is not vary with the load. So that we can take omega naught as a rotational loss. Then we have to find the net power is nothing but the difference between forward power and forward rotor power minus backward rotor power. By finding PF and PB we are able to find the net power. So PF equal to I2F square into R2 by S. We know that F refers forward rotation, forward rotor circuit. For forward rotor circuit we are divided with S. I2B square divided by R into R2 divided by 2 minus S. This B refers backward rotor circuit. For that backward rotor circuit we are dividing by 2 minus S. Right. Then how will you find this I2F? This power is calculated from this formula. In that what we need is current, forward current and backward current. Forward current is Vf divided by R2S plus Jx2. Similarly backward current I2B equal to Vb divided by R2 divided by 2 minus S plus Jx2. Right. From that we can able to finding these two we are able to find the current, forward rotor current and reverse backward rotor current. Now we'll see the further detail. In order to find the I2F and I2B, what we need is VF and VB, forward voltage, reverse rotor circuit voltage. So first we will find VF and VB, then we'll go for I2F and I2B. So VF equal to I1 into ZF. This I1 value we know, just now we calculated. In order to find the power factor we calculated I1. ZF also already calculated. Forward rotor impedance and ZB also we already calculated. So from that we can easily calculate VF. So this is the current value, 17.6 angle 47.53. ZF is 6.475 plus J 3.4108. So this rectangular form is converted into polar form so that we can multiply these two magnitudes, adding these two angles. For multiplication we have to add the angle. So it is 128.8056 with an angle of 19.76. Similarly VB, I1 into ZB. ZB also already calculated. That is 0.1755 plus J 1.86048. This rectangular form is converted into polar form. These two magnitudes are multiplied, angles are added together. That is 32.88 with an angle of 37.079. Now we calculated VF and VB. From that we can easily find the I2F and I2B. Now we'll see how to find the I2F. I2F equal to VF. Just now what we calculated, R2 divided by S plus JX2. All these values are available. These values are substituted and further simplified. Then this rectangular form is converted into polar form. Here these two magnitudes are divided. Is divided, so it is 16.0645. The angle what we need to subtract 19.76 minus 14.30. For multiplication angles are added, for division the angles are subtracted. So it becomes 34 minus 34.06. Similarly we can find the ZB value. VB divided by R2 divided by 2 minuses. Backward reverse 2 minuses plus JX2. All the values are substituted and simplified. Now we need to convert this rectangular form into polar form. So that is converted into polar form. Now divide this two parameters. So it is 16.5148 magnitude. Angle we have to subtract 37.079 minus 84.258. So it is, we got negative value, minus 47.179. So now we calculated forward rotor current and reverse backward rotor current. From that we can find the forward rotor power and reverse rotor power. PF equal to I2F square into R2 by S. Here R2 by 2 minuses, backward circuit. So this value what we calculated is substituted here into R2 value and S value is given 0.05. So it is 2005.1896 watts forward rotor power. Similarly reverse rotor power is 2 minuses is substituted. So what we calculated, after simplification we got 54.33 watts. So the net power equal to 1 minus S into PF minus PV. So these values are substituted. So final net power is 18,853.31662 watts. Right. So that the P out we can calculate. P out equal to PM minus rotational losses. After if we subtract the rotational losses, we get the total output power. The rotational losses already given is a no load power 350. So 1503.3166 watts. So this is the net power output. What is the net power input? P in V1 I1 cos pi 1. These three values are already available. This pi 1 also we calculated power factor. So 2614.3744 watts. Now we have P in as well as P out. So you can easily calculate the efficiency. Efficiency is P out divided by P in into 100. P out is 1503.3162. P in is this value 2614.374 into 100 is 57.5%. So the second parameter, this efficiency also calculated 57.5%. Right. So the two parameters, power factor and efficiency calculated. So in this we discussed the solved problem based on the single phase induction motor. The test results are given, no load and blocked rotor test. From that we are able to find power factor and efficiency. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.